Good morning to you all.
Good morning, sir.
Yeah, so we are about to start now. You start, you must identify yourself by your name, your matric number, your surname, and the other names with your department, as usual. Your matric number, your name, your department, your department. Please, can you hear me? Hello, can you hear me? We are about to start.
Yes, sir.
So let's go straight. Let this fellow who raised up his hand drop the hand for now, because I don't want to. We have already missed about 30 minutes and we have a lot to do. So we want to go straight to number of things. We know mesh. I told you that you have a source in between them.
So we can't see your screen.
Even if network is bad, yeah, we log down again.
So we can't see your screen.
So we can't see your screen.
I was saying that last week, is the network a lot better now? Is the quality better than before?
You can see it now, sir.
Yes, sir.
Okay. I was saying that last week we looked at the rest of the nodal analysis by looking at supernode, which is a problem of that comes up whenever you have a source, a supply source between two non-reference nodes. Then from there, we went to mesh analysis. We're able to see a number of meshes. From there, we went ahead to look at super mesh. This morning, we want to go straight away and look at linearity, superposition, linearity theorem, superposition theorem, as well as um, a source transformation. So that's what we are looking at this morning. These are the topics for this morning. So it's not a long lecture. I believe we can finish it in the TV. So please carefully pay attention. Try as much as possible to ensure that your network is that your lecture note, you have it in place so that you can be totally involved in the whole lecture. So at this point now, I want to move straight away to what we need to look at in this place. So when we are talking of linearity, it means that the source is the linearity property of any circuit or network. And what does it mean? Linearity property is the linear relationship between cause and effect of an element. I taught you earlier on, I think the second week of our lectures, we looked at what's the name? IV characteristics. And if you look at the IV characteristics of most of the elements, they are more or less linear in nature. So that's what we are falling back on when we are talking of linear property of a circuit. So this property gives linear and non-linear circuit definition. The property can be applied in various circuit elements. Linear elements are the element characteristics of voltage and current, just like as I taught you in week 2 of these lectures. And that means your voltage current characteristics are always a straight line. They are always straight lines through the origin. So that's what we mean by IV characteristics. For example, the current passing through a resistor is proportional to the voltage applied to the circuit. So on the account of that, you have VI or V equals to IR, which is what gives us the IV characteristics. So a linear circuit or network satisfies the principle of superposition. So superposition, that is principle of homogeneity and additive. By the time we get to what superposition is all about, we understand better. But what we mean by superposition is that you are imposing one part of the network on the other. So in this case, we have the resistor, inductor, and capacitors as examples of linear elements. And the property do not change with a change in the applied voltage. Whereas in non-linear elements, IV characteristics do not follow the linear pattern, just like the name suggests, that is a nonlinear system. Examples are semiconductors, such as diode, transistors, and things of that nature that we use, especially in semiconductor, for the network. So in other words, our passive resistance normally give us linear situation, while the active elements may not be linear. So that takes us to so when we are talking of linearity, there are two major properties that we look at there. Additive property, which is, as you have seen it, you have voltage Vs, you have linear circuit, and you have resistor at the other side with current flowing through the resistance. So in this place, you can break it into two. You will have current flowing through the resistance, which can be I1 plus I2. You can have V1 as I1R, and you may have another resistance, V2 equals to I2R. So that is a relationship between voltage and current of a resistor. So at the end of the day, you will add the two together to get what we have on that. That's what we mean by additive. You disconnect one and you work with the other one, and you now add the two together. The same thing we have done here. You have IX, I1A, X2A, up to the number, maybe SNA. And it's equal when it passes through the linear circuit, it gives us an output which is YA. And you have another which is from the same source, XIB, S2B up to SNB. And then the output as well is YB. In additive property, all you do is that you add SIA plus SIB, you add S2A plus S2B, and in the output as well, you add YA plus YB. So that's what we mean by additive. You add the like together in order to get your full answer, or to know the nature or the what is going on within the system. So additive property is more or less following the Ohm's law. In any linear bilateral network containing more than two or more independent sources, that is, it can be voltage source, it can be current source, you have to break it down. The resultant current, in this case, will be the algebraic sum of the current caused by each of the independent sources. Please take note of that. For any linear bilateral network that has more than one sources, more than one source, two and above, if he has that number of independent sources, that is, be it voltage or current source, you have the privilege and the freedom to split it into the number of sources that it has, work them individually or independently, and then you can now do the break sum of all of them together to get the total action or total influence and what is going on within the network. That's for additive. Another property of the linearity is homogeneity. The homogeneity property is that if the input is multiplied by a constant value, if the input is multiplied by a constant value, you are going to get, then the output is multiplied by the same constant value. Take note, homogeneity means that if you multiply the input by 10, you must multiply the output by 10. The homogeneity, or what we call scaling property, and the additive property are both needed in the linearity property. Homogeneity, which some textbooks may call scaling property, and then the additive property, they are very important in linearity property. The homogeneity property requires that if the input is multiplied, I've said that for a resistor, for example, Ohm's law relates the input I to the output V. So if you have V equals to IR, if I is increased by a constant K, then V must be increased by the same constant K. So you have KIR equals to KV. That's homogeneity for you. So with these two properties, we can now come to superposition. What is superposition theorem? Superposition theorem is a strategic use of, is to a way, as I've said under additive, is to eliminate all but one source of power supply within a network at a time to eliminate all but one. You will eliminate, if you have 5 sources in a network, you will eliminate 4 and you will leave only 1. Then you will use series and parallel circuit analysis techniques. We have looked at series and parallel circuit analysis technique. We have looked at it. It's what we did last week. Technique to determine the voltage drop and current within the modified network, because that network is becoming modified because you have removed all the sources except one. So you will do it for each of the network. When you are through, if you are through with the first one you remove, the first one you analyze why you took away the other 4. You will keep it aside, and then you will remove it and place another one out of the remaining 4. You will place another one when you are through with that out of the remaining 3. You will place another one out of the 2 after when you are through with the 3, and then you continue until you do the last one. Immediately you are through with the last one, what we were taught in additive is that you will add all of them together to get your final answer. This process is repeated sequentially by individually evaluating the circuit parameters, that is voltage and current. And by the time you are through with all this, you superimpose them on top of each other. That's what brings about superposition. You superimpose them upon one another. That's what brings about superposition. So, as I have said, the superposition theorem is one of those strokes of genius that takes a complex subject, simplify it, and break it down in a way that makes sense. So the superposition theory principle states that the voltage across or the current through an element in a linear circuit is the algebraic sum of the voltages across or the currents through that element due to each independent source acting alone. As each of them is acting alone, then you take note of the current flowing through it or the voltage across the element. So at the end of the day, you will add all of them and superimpose them. We must keep 2 things in mind when we are dealing with superposition. Number 1, we must consider one independent source at a time, while the others are turned off. Take note of that. You must keep 2 things in mind. Number 1, consider one independent source at a time, while the others are turned off. In other words, replace every voltage source by 0 voltage, which is short circuit, and every current source by 0 current, which is open circuit, to obtain a simpler circuit. And then, while the independent source are left intact, since they are controlled by circuit variables. Where the dependent sources are left intact because they depend on the circuit variables. So what are the steps if you want to work it out mathematically? Number 1, step 1, turn off all independent sources. You remember, it is independent sources. All the dependent sources, you cannot turn them off, except one. Find the output due to that active source. Then, step 2, repeat step 1 for each of the other independent sources. Step 3, find the total contribution by adding algebraically all the contributions due to the independent sources. So what is the superposition theorem? I have it here for you, which is all what we have said. It helps us to analyze linear circuits with more than one source of voltage or current. Who is this? I will throw this guy out of my lecture. So superposition principle helps us to analyze a linear circuit with one or more than one rather, as I've said, more than one circuit of voltage source. Sometimes it is easier to find out the voltage across or current in the branch of the circuit by considering the effect of one source at a time. So look at this. I know in engineering we don't like too long discussion, but I have to go through that route so that I can lay some foundations for you. So look at this particular, when you are applying superposition theorem, look at the original circuit. It has two voltage sources, B1 and B2. That is battery 1 and battery 2. And our superposition theorem says that we must only make one independent source active at a time so that we can get what that particular source is contributing to the whole network. Then when we are through with it, we go to the other one while we remove the one we have done the analysis. And then we now add the two together when we are generating our final answer. So you can see for the 28-volt source, we make it active for the first time, and then later we remove the 28-volt battery, and we made 7-volt battery active. Recall that one of the things that was stated when we were going through it is that your current source, look at this, I said you should put two things in mind. I said your current voltage source, every voltage source should be treated as a short circuit. I hope you have not forgotten this. Every voltage source should be treated as a short circuit. Look at what we did under this place. The 7-volt battery, we short that terminal. We short out that terminal. While battery 28-volt was short out for the second analysis, when 7-volt was active. So this you must not forget. You short out the terminal of the voltage source, and for the current source, we use open circuit. Please don't forget that. So when you are doing additive, this is what we mean by additive property. You have V1 and V2. So the property is that V1 plus V2, I21 and I2, I1 plus I2. You can see open circuit here. Open circuit here. When we were dealing with only V1 as the active elements, I2 was open circuited. When we were dealing with I2 as the active element, as the active source, then we shut down not active element, please, because they are not active. The issue is that they are more of active source. We take V1, we take I1 as our active source, we open circuited I2. When we took I2 as our active source, we open circuited I1. Please take note of these principles. They are the major things that you need to know. You can work with Ohm's law all along, so I don't have problem with that. But when you are doing it, know which one you are to open circuit, which one you are to short circuit. When you get your values, you then add them together in the case of using additive and homogeneity property to do that. So I may not do beyond this, but let me quickly go ahead and show you something. I've taught you current divider method. It will be of great use in this place. That's why I revisited it again for your knowledge. That when you are dealing with current divider rule, you have your current, total current flowing into two branches. Then what is the current that will flow into each? What will flow into each will be a reciprocal of what will flow into the other. So the major thing I would want you to take into account is that when current I1 is flowing through R1, what will be your numerator will be R2. Take note of that. R1 will not be part of the resistors. Let's assume you have 5 resistors parallel. R1 will not be part of them. 3 other resistors, you will multiply them together. R1 will not be part of it. If you are considering I1. If you are considering I2, R2 will not be part of your, it will not be part of your numerator. I mean numerator. Denominator, everything, you will add them together. So please, that's the best way I can explain it. But if you want to walk it through, I have shown how you can walk it through. It will make sense to you. RT, you got the total RT, which is how do I call it? Penny's equivalent of all the resistors in that circuit, or R equivalent of the resistor in that circuit. So in the case of voltage divider, your voltage, the voltage passing through R1, if you want to get V1, the R1 is the most important element. So R1 will have an influence on voltage that will drop across the resistor R1. So we take it very, very serious. R1 will be your numerator multiplied by your voltage divided by your total R. Please don't mix these things up when you are working the problems. So I say, okay, now let me see you. Can you do this using voltage divider method? Determine the voltage V1, V2, V3, V4 for the series. Oh, I didn't give the question complete. Where is it? Okay, don't let me worry myself. So let's assume for the sake of knowledge now, can you write down now for this particular circuit? For this particular circuit, I want you to write R1. Are you with me over there?
Yes, sir.
Yes, sir.
Yes.
Yes,
Draw
sir.
this circuit. Let R1 be equal to 5 ohms and R2 equals to 10 ohms. While our current IT is equals to 2 amps. Calculate the I1 and I2. I1.
Please, can you come again, sir, with the values?
Yes, R1 is 5 ohms. R2, let me go to the chat box and put it there. R2, R1 is 5 volts, 5 ohms. R2 is 10 ohms. IT is 2 amps. Obtain I1 and I2. I've sent it to everybody. Obtain I1 and I2. I'll be calling names any moment from now. Ogunjobi. Is Ogunjobi in this class? Ogunjobi.
Good morning, sir.
Yeah. Can you show me your working?
Yes, sir.
Open, you can share your, let me drop my own slide so that you can share your own. I'll give you the privilege now. Show your note.
Okay.
So you have the privilege to show your note now.
So please give me a minute. I want to switch to my phone.
No problem. No problem.
Okay, so I'm here now. Sure.
You should be able to share now because I've dropped my own privilege.
Oh, yes, sir.
Okay, it's coming up. Show us your notebook.
Coming. So sorry, I don't know how to use this. Okay, so can you see it?
Yeah. I believe, guys, you can see it.
So I didn't write the formula, but I1 should be R2 divided by R1
You
plus
didn't even draw the circuit diagram, Oguntobi. How will you remember when you are revising?
So
If you don't have the diagram,
I screenshotted the slide.
okay.
Yes, sir.
Okay. But I will have loved to see your diagram now so that you can use, because in circuit analysis, we use diagram to explain ourselves. So you have to show your circuit for people to really get what you are saying. How did he go around the circuit to get what? Can you quickly draw that circuit now?
Okay.
I know some people have worked it, but at the same time, I just want to be sure that everybody we are together.
And then you have
Your circuit is always very, very crucial in your diagram of your circuit. We always help you. Somebody has sent his own answer to me. I think another girl has sent her own answer to me directly. I gave you RTO. I saw you the direction of IRT.
Yes, it was here.
Which is your That's why I said you must always be.
Okay, sir. So I did I1 was R2 divided by R1 plus R2 times I2. So the R2 was 10 ohms, R1 is 5, and then
so
I2.
how did you know? How did you get this formula?
Sir?
How did you get the formula of R1? I1. You put I, you didn't put I1. You said I is equal to R2 over R1 plus R2. You didn't put 1 there.
So I didn't put 1.
In your formula.
Yes, sir. Oh, sorry. There should be I1 here. Then
so how did you get that formula? Explain it now. Go back to your diagram and use it to explain it to us.
Okay, sir.
Many boys have gotten it and a guess. They have been sending it to me.
Okay.
Show us your diagram. I just want to go back to that circuit diagram and use it to explain. That's what I'm saying.
All right.
If you don't know how to explain, it becomes difficult for you to apply it when I give you complex problems. Because I will not give you this simple problem when we are doing certain other things. So if you don't know that's why I'm calling you now, guys, to give me, if you have the fundamental understanding, let them put 100 parallel circuit together, resistor together. You will still be able to analyze it once you know the principle behind it. So that's the principle I want to know.
Okay, sir. So you find the effective resistance, that would be R1 R2 divided by R1 plus R2.
How did you get that effect? What do you mean by effective resistance?
That's the resistance, the total resistance combined of R1 and R2. R1 and R2 are in
What
parallel.
principle did we apply? What principle do we normally apply here when you want to find that R total?
So I'm
You
not
don't know.
sure. Yes.
So you don't have the basic understanding of this.
So I do. I'm not sure about what the principle is. Hello?
You don't have basic. No. You don't have the basic of your diagram. Set it up. Don't do your camera. Now, guys, I have seen your answer. Thank you. I appreciate that. Don't worry. Please let me just explain. I know I can call another person to explain, but because of lack of time.
So can I turn off my camera?
Don't turn off your camera. I'm using your
sir.
notebook to explain to your colleagues.
All right.
Okay. Yes, there is a shadow casting on it, which I don't want.
The shadow.
Casting on the RT. You have removed it to. Okay, better. Just leave. No. You have removed the RT from the screen.
The RT is the RT here.
No. Just leave. You have removed it again. Just move it back. Okay, leave it like that. Let it be stable like that.
Okay,
now, this RT, you can see the direction of the arrow. What I mean by that direction of the arrow is that you are looking into that parallel circuit from that direction. And whenever you have parallel circuit, and you know that you cannot add them together the way you will add series circuit. That's the reason for that RT there. And that means you have to use parallel combination of resistance. And I taught you the principle of parallel combination of resistance. That was, I think, second lecture or third lecture. So what we are using here to get RT that he has gotten is parallel combination of resistors.
Okay, parallel.
And now did we come to say it's a parallel combination? If you look at the direction of the current, I taught you something about direction of the current. That IT, when he got to a junction, he had a decision to make. So because he has a decision to make to either flow as I1 or to flow as I2, then anything after that point of that junction is no longer series. They are now parallel combination because he has two decisions to make, either to go to I1 or to go to I2. So he can decide any one, but your own joy is that from this junction, resistors are no longer series. So you can use series combination of resistors or resistors. So you have to go back to your knowledge of parallel combination of resistor. And your parallel combination of the resistor, if you have two resistors, you will have the product of the two on top as your numerator, and you will have the sum of all your resistors under. If I have three, this game may have challenge to resolve a three parallel resistor. If you do not have the knowledge of this, you will have problem of resolving more than two parallel resistors. It's because that's what I showed in my own explanation. So on the account of three now, what will happen is that you will always have two combined together, two of them. You can if I have R1, R2, R3 together as my parallel combination, and I want to get the current through each of them, what I will do is that I will do R1, R2 plus R2, R3 plus R1, R3. And then I will say that will be my numerator. And then the denominator will now be R1 plus R2 plus R3. So that by the time I'm getting my R total, which is RT in this your case, I'll be able to get the resistance. I will get the total resistance on top. We have ohm square. And under it we have ohm. And 1 ohm will cut out 1 ohm. And then you will have your resistor ready for you. So please, the fact that I have taught you certain things in the past does not mean they are not useful. Everything I'm teaching you, I have been painstaking in teaching you, so that nobody will teach you these things again. It's application you will go to. Even by second semester, we won't teach you again. That's university system for you. Foundation is laid upon one another as we go on. So when you don't understand anything, you will have the principle behind it. Once you know the principle, We work with principle in engineering. I told you my experience when I was in year 2 electrical engineering at University of Nigeria, Nsukka. My professor of thermodynamics taught me this kind of way I am teaching now. Anything he's doing, he will say, I don't know more two things. I don't know anything. Every problem is solved for us when we were doing thermodynamics. It's in mechanical engineering. He's a professor of mechanical engineering, but he was teaching us. Professor Odukwe then. Professor Odukwe then. So he was teaching us. Time is to solve any problem for us. Throughout the 2 sessions that we did thermodynamics, he would say, I don't know anything. All I know is 2 laws of thermodynamics. Which one am I going to apply here? He will always take us back. And so I had to go back to other courses like electrical and civil engineering that I was doing. I must be good in my year 2 courses so that I can be able to be sure of my future as an engineer. So I'm passing the same principle to you. I'm passing the same tradition and culture to you. Don't know too many things, but know the principle, the foundation. Once you know foundation, every other thing becomes easy. Engineering, that's why people will see us. We have 50 first class, we have 21 first class. Like this year now, the first class from engineering will be nothing less than 40. Nothing less than 40. And friends will ask us, how do you do it? Because the guys know the principles. All you need to know in engineering is principle. Once you know principle that is resulting in what you are to do, then you don't have problem. But when you try to juggle things up and you don't know the foundation, it will be tedious for you to continue with us. It will not be exciting. Engineering is exciting. It's very exciting. You are able to create things by yourself. You are able to establish things by yourself. When you see what you have created, you are so joyful. That's our trade. But if somebody does not have the understanding of these little things, I'm not just saying in electrical. Even when you are doing mechanical, I just told you now, the inspiration I got was from my professor of mechanical, who taught me in year 2. And that's why we teach you in year 2, either professor or senior lecturers who have been in the system for long and they know the challenges of students. So please, I'm appealing to you. Know the first principle. If I'm teaching and you don't know the first principle, ask me, sir, what's the first principle here? Then we take you back to Ohm's law. And we take you back to Kirchhoff's current law. We take you back to Kirchhoff's voltage law because we are not using any new thing. Those are the rules that we are using here. And the principle of parallel combination, which I've taught you, series combination. These are the foundation. Once you know the foundation, you don't need to be my friend for you to get A. And I appeal to you, all your year 2 courses, you are just starting with us. All your year 2 courses, don't miss this principle. Always ask the lecturer, what's the principle behind it? Once you can tell me the principle, if the lecturer could not, you don't have opportunity of asking the lecturer, maybe for one reason or the other, you can pick up textbooks and get the principle. Once you know the principle, you are settled in engineering. You'll be the best of my friend. And I will be sure that this one that is going is a first class brain. We will get first class out of this system. So I need you to go back to first principles for every course that we will be teaching you. We are not teaching you things that we are not using abracadabra. We are not using magic. Engineering that is not established on principle and laws and rules is not engineering. And when I started today now, I told you there is law or rule or I told you principle of superposition. I said superposition theorem. Theorem is out of theory. And then I told you about additive property. I told you about homogeneity property, which is a book. They will call it homogeneity rule and additive rule. So please let us go back to the first principle when we are dealing with engineering. So that's the information I just need to pass before we continue. Thank you, Ogunjobi. So we can move on now. I have seen many of your answers. They are very correct. So we need to move on from there. I just felt I should. So this is another circuit. And this is voltage divider method that I was telling you. We have done this before. We have done this before. So we have done it before. So I may not need to take you through this again, except if I have questions. If you have questions when I'm through with the lecture, we can now go to that. So superposition principle, we have established it, and we have told us the steps we need to adopt, that you will replace all independent source with their internal resistance except one source. And then we find the output due to that active source, or what I will call, yes, active source, using nodal or mesh analysis. In other words, the current I2 in the resistance of 3 ohms due to voltage source of 20 volt alone. And that will give us the current as we have it. I2 is equals to 2.5 amps. Then you do that of this is the old circuit that you have. This is the old circuit. Sorry. So when you are through with 20 volt, you do for 5 amps as well to get the current that is flowing in 3 amps. So you see now, we have removed the current, the voltage source. Remember, the voltage source is here, 20 volt, but we have stated that replace all independent sources with their internal resistance, except one source. So the internal resistance for 20 volts is 5 amps, 5 ohms. 20 volts, the internal resistance for it is 5 ohms. You can see that's what is here now. That 20 volts is gone. We said you should always leave, close it and make it an you should short it so that it will not have any impact. But for the current, we open circuit it, we short circuit the voltage. But if the source has a resistance, you let the resistance replace it. But if there is no resistance there, you just remove the voltage or current source. So that's what we have done in this place. So if you do that, IS or I5 amps, whichever one you want to call it, let's call it I5 amps, is equal to I times, I've told you that R1 over R1 plus R3. So if you are to do that, we have 5 ohms, 5 amps times 5 ohms over 5 ohms plus 3 ohms. 5 ohms plus 3 ohms. You may want to ask me, why is 10 ohms not part of it? Because whatever current that is flowing through 5 amps will flow through 10 amps. And what we wanted to ask, or what we want to discover, is what is the current flowing in 3 ohms resistor. Remember, that's our I. So we said the first one is that we first of all remove 5 amps source. So we have this. We were able to calculate the I2 as this for this I20. Then if you are to leave that now, this 20 volt now, you are going to short it and allow this, circuit it, and allow these 5 ohms, which is his source resistance, to replace it. then you will have what we have here. So the 5 ohms is in parallel with 3 ohms. You may not easily know that until you are moving from this current source. And when you get to this point, this junction, or this node, you have a decision to make, either to go to 3 ohms or to go through the route of 5 ohms. So you will know that 3 ohms and 5 ohms are the only ones that are in parallel. And by our parallel circuit principle, you will apply it in such a way that you'll be able to get my voltage divider method. So your voltage divider method, which I revisited at the initial stage of this lecture, is what we applied here. So you will see that the current flowing in I5, that is this 3 ohms resistance, due to 5 amps source, is the one that we considered. So on the account of that, you have 5 amps times 5 ohms divided by 5 plus 3 ohms. That gave us this. So by the time you put the two together, you will have I2 plus I5, which will give us 2.5 plus 3.125, which is 5.625 amps. So that's about that. Before I go to source transformation, I saw someone's hand up. Yes, can I hear your question? Okay, let me start with Adebisi. Then Alozie will come in.
Good
Adebisi,
morning,
can we
sir.
have your question? Yeah.
Good morning, sir.
Yeah,
Sir,
good
my
morning.
question, first step you took when you want to start, where you open the current, like when you open the current, there's a question I want to ask from that slide, sir.
Okay, I should go back to the currents,
Yes,
the one that has current.
yes, sir.
Okay,
Yeah, this
when I
one, sir.
remove this, yeah.
Yeah, sir. And sir, I just want to get this straight. I want to get it if what I'm assuming is actually correct, sir. So if the current flow from 20 volts to 5 ohms, does that mean that the current is not flowing through this 10 ohm because it is open, and all of the current flow from 5 ohms to 3 ohms?
Okay, let me
Because
see.
the equivalent resistance here is showing that it is 5 ohms plus 3 ohms. So I'm assuming that the current flows from 5 ohms down to 3 ohms because the 10 ohm is open. So our current can flow through an open circuit,
I
but
can't
with
even
voltage
see.
source.
Go on.
And so that's my question,
Go
sir.
on, listen.
And so that's my
Take
question,
that
sir.
question
And
again.
my question is that does it mean that all the current flowing from 20 volts to 5 ohms, all of them flow to 3 ohms? None of the currents flow through that 10 ohms. Is it because of it is open? Because the equivalent resistance here you are showing is that it is R1 plus R2, which means the 5 ohms and the 3 ohms are all in series, excluding the 10 ohms,
Yes,
sir.
thank you. Read our statement under. Can you read it out? Read it out so that we can explain it together. Adebisi.
Okay, sir. And
Step one.
replace all independent sources with their internal resistance except one source. Find the output voltage or current due to that active source using nodal or mesh analysis. Thus, the current I2 in the resistance of 3 ohms due to the voltage source of 20 volt alone with a current source of 5A open circuited.
Thank you. So on the account of your knowledge of analysis of Kirchhoff voltage and current law, when you open a source, then voltage will not flow because you must complete the circuit. And remember, this is superposition. The contribution to 3 amps is what you are looking for. So if that is correct, 2 sources are supplying that particular resistor, as you well know. So the first one that is supplying it, which you will still do in laboratory, I love the question you have asked. And that's why we make superposition theory, theorem, one of the things you must study in the laboratory so that you will be able to appreciate what we are saying here. So I want you to still put this in mind by next year when you'll be going through labs, experiments, you will find out that what we have done here, by the time you experience it in the practicality of it, you will know that it's very, very correct. But I love the way you have thought out of the box. But these currents should not only be restricted to 3 amps. I get what you are saying. So you believe that because 5 ohms is drawing the current, that it's as if the total current is still going through the same current going through 5 ohms, is the same current going through 3 ohms. And that you have thought out that when you get to a junction, there will be a decision to be made that some current will flow through each of them, no matter how small. So I understand quite well your thought process. I totally understand it. But this is because of the open circuit that we have here, no current will flow through that place. Our principle has taken care of that. And if you try to use any other method beyond superposition, you can use other methods to still solve this problem.
Yes, sir.
You can use your voltage divider method or current divider method. You can use it to try whether what we have done here is correct or not. Now, okay, I don't want to remove anything. Let me see the current that will flow from current source through these 3 amps. And let me see the current that will flow through the voltage source through these 3 amps. And I will now see whether this method is correct or not, which is what I will ask you to do after this lecture. And if you have challenge, you can get back to me. But because of that open circuit, no current will flow through the 10 ohms resistor.
Okay, sir.
And then you will have 20/8 to give us 2.5 amps. I don't know whether anybody understands why this guy is asking this question. He wants to know that at every junction, you told us that current must flow to the 2 sides. But now, you are telling us this now, but because we are dealing with superposition theorem, no current, once you have open circuit, that a circuit does not form a complete cycle. Circuit is from the word cycle. You must be able to go around it. But in this case, you can't go around it. So it's more or less not contributing anything in this perspective. Adebisi, does it make sense to you now?
Yes, sir.
Okay. Please don't be confused. When the circuit is completely drawn and there is a closed path, you will have current flowing through each of the resistors. But when the closed path has been broken off, anyone that belongs to that broken off path that is not able to complete a circuit, current cannot jump through a gap. Current cannot jump through a gap. Please take note of that. So it will not be able to conduct, and it will remain as lifeless as anything, or maybe I should say as inactive as anything. So when you get to lab, you are going to work with superposition theorem. It's one of our major lab. And I will still want you to put this in your mind when you go to that lab. No matter how choking the time is, try to ask and see and measure very correctly by yourself to be sure that this thing truly is working. Any other? Okay, Aibu. Is it
Sorry,
Aibu or
no,
Alozie?
Aibu.
I think it's
Me,
Alozie.
sir. Yes, sir.
Yes,
Morning.
Alozie, go on.
Yeah. First of all, Adebisi asked one of the questions that I wanted to ask. So one of the questions that I wanted to ask has been answered already. But then I wanted to know, how
Are
did we
you convinced
determine?
with what I've told one by one? Are you
Yes.
okay with the
Yes.
answer
Yeah.
I've given? Okay.
Yes, sir. Yeah. So I wanted to know, how did we determine that the internal resistance of 20 volts was the 5 ohms resistor? Because in essence, that's not the definition of like internal resistance in quotes. Why did you just replace the? If you go to the next slide, you simply replace the the
I
20
know.
volt battery source with the 5 ohm resistor. So I don't understand how you did that.
Okay. Now, you know that for every voltage source, they always have their the resistance connected to them in series. It's always their internal resistance. Do you agree with that? Hello, say
Yes,
you don't
but
know. You don't know. Okay, you
yeah,
don't
I
know.
didn't
Okay,
know.
let me restate it. When you have a thank God that I even brought this up because I think I have taught you under the okay, I will teach you under the source transformation now. I will teach you under the source transformation. But let me just quickly say this. When you have, did you remember that you were talking about internal resistance? Hello, say I'm still
Yes,
talking to
sir.
you.
Yes, sir. Yes, sir. Yes,
When
sir.
you are talking about internal resistance alongside with voltage, how do you normally connect the internal resistance and the voltage source?
How do we connect the internal resistance and the voltage source?
In your physics in
You connect
secondary
it
school,
in
don't think.
series. You connect it in
Thank
series.
you, thank you, thank you. So it is believed, it is assumed, and it is expected that this resistance, because it's connected in series with the voltage source, it will be its internal resistance. You may go to another place, there may be no resistance. When there is no resistance, you remove it. I have done one for you before now, and there was no resistance. Let me, I think I did one, that there was no resistance anywhere. And we just assume that if I've done that, this I will come to this. Oh, I thought I've done it before. So if there is no resistance there, you just represent it by short circuit. You just draw a line that does not have any resistance connected to it and no source connected to it. Does that make sense?
Yes, sir.
Okay. So your internal resistance, as you were taught in physics, that still put pay to what I've told you before. That all the principles we are teaching you, they are things that you must hold tight to. Because those are the things you will be working with after you have left here too. And even for some of you that you will become practitioners in life, you will find out that you will keep on going back to this first principle. The first principle my professor taught me, Professor Odukwe, of blessed memory now, it is still helping me. So the internal resistance is always connected in series with voltage source, while it is always connected in parallel to current. But when I get to source transformation, we will look at that. But just
Okay,
please
sir.
bear with
Thank you.
me. Maybe I should have taught you source transformation before teaching you this, but I was following the syllabus the way it is laid out for me.
Okay, sir.
So, okay. But you don't have problem with that internal, the one with the current source. You don't have any problem with it.
No, 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 no. I have no problem with it. You simply
Okay.
reapply the superposition
Okay.
principle and then
Okay.
put the currents together. I understand.
Okay. Okay. So I believe everybody we are on the same page now. Okay. So I want to quickly
Yes,
move
sir.
to, I will give you some superposition problems, but not now. Let me move straight away to source transformation. Source transformation. I want you to look at this before I speak. I believe you can see my slide. Please look at this before I speak. I want you to internalize it, ruminate over it, synthesize it within you, then I will now speak. I'll give you 60 seconds to do that. My 60 seconds is remaining 10 seconds now. Okay. Now, when we are talking of source, we are talking of the voltage source, current source, the independent voltage source and current source. That is the one that can pump out energy from its own reservoir. So when we are talking of such, we have a situation of this nature at hand. So a current source or a voltage source is the one that drives current through its resistance resistors, or is the value of the load resistance. So when you are talking of, thank God that one of you have raised observation, and thank God we are here now. When we are talking of voltage source, a voltage source, we always have a resistance. We have a resistance in series. That resistance in series, we call it internal resistance. You already know that from your knowledge of physics. Is my network okay?
We are hearing you, sir.
Okay. I just want to be sure you are hearing me. I don't want a situation whereby we will not be on the same page. Please look at this closely. And when you are talking of voltage source, the resistance is always in parallel to it if it is that resistance. So I will leave you to look at that for 1 minute again, because I'm going to somewhere which Alozie has spent a serious thing for me to really take time to teach you this.
So we can't hear you.
Okay. I just want you to look at it again. So looking at it, look at what I call voltage source. I wrote something under the circuit. Can you hear me now?
Yes,
Yes,
sir.
sir.
Okay. Under this first circuit, the one that has voltage and R resistor, you will see that I wrote voltage source. That particular voltage source and resistance, I can transform it. That's what we call source. But I can transform that voltage and resistance to current and resistance. So that's what we mean by source transformation. How do I do it? Look at the next circuit. After my arrow, my green arrow, big green arrow, that old green arrow. You will see that I called the circuit underneath. I captured the circuit as what? Equivalent current source. Maybe you are not looking at what I'm looking at. Look at the underneath.
Yes,
We are
sir.
looking at
Yes,
it.
sir.
Okay. So equivalent current source means that it's equivalent to what we have for voltage source. This is very crucial. That's why I'm very, very careful to run or to rush it. So in the case of voltage source, just like Alozie asked me, the resistance that is in series with it, as we were taught in physics in your secondary school, I know that electricity, when you were taught electricity and magnetism, you were taught that that's what we call internal resistance. Some of you would have even worked with it when you were doing your practical laboratory during your WAEC or NECO exam. So on the account of it, that resistor that is in series with the voltage is called the internal resistance. Please take note. It is the one that can be transformed, and you can transform it to suit whatever you want to do to a equivalent current source. And in the equivalent current source, the current source and the resistance, that internal resistance now will be in parallel with voltage source. That's where I'm going to. Under the equivalent current source, that internal resistance that you have as R under voltage source has now become a parallel resistance across the current source. And how do you get your current magnitude for that current source? It is your voltage in the voltage source divided by the resistance, which is the internal resistance in the voltage source. Can you see what I'm saying?
Yes, sir.
Yes, sir.
Okay. So you must not in any way forget this principle. It becomes very when you have a complex circuit, where these resistors combine together and you have more or one or two or three sources of voltage or current. So you will continue to swap. Where you have current source that is blocking your way to do your equivalent resistance, you can change from current source to voltage source, from voltage source to current source. You can flip-flop based on these two things that I have shown you. And you can see again the pair of circuit, the next two set of circuit beyond the one I have looked at. After I've looked at voltage source and equivalent current source, you will see another pair that I wrote caption under them, voltage source and current source. You can see my arrow. The two side arrow. The arrow that can go both to the right and to the left. That means the principle of source transformation that I showed to you in the first pair is not restricted to just moving from voltage to current. You can move from current as well to voltage. Does that make sense to us?
Yes, sir.
Yes, sir.
You can move from current to voltage and voltage to current, depending on your need at every point in time. And then you can see if you are moving from current to voltage, that's why I put the third pair of circuit there. You can see that source current is equivalent in voltage current. You can see it Vs now. You can see instead of current source now, we have voltage source. And the resistance that was in parallel to the current source before is now in series with the voltage source. And then the voltage source is now IS R equivalent or R internal, RINT. So you can see the flip-flopping that you can do there. I trust that we will have some things. So this is what we should know about source transformation. Number one, it is a technique that to simplify circuit analysis. Now you can move from voltage to current conversion. You can move from voltage to current conversion. Please let me change my source of electricity. Electricity has been ceased here. So, thank you. So, on the account of what I've just said now, voltage to current conversion, you can see it. It involves circulating the current supplied by a shorted voltage source and connecting the same resistance across the current source. But when you are moving from current to voltage conversion, convert a current source into a voltage source by applying Ohm's law. Then circuit simplification. Such transformation allows easier analysis and understanding. So you can see, this is what I've done with you earlier on. So you have in this, look at the first set, they are the independent source that I've taught you before. And the dependent source, remember I told you for dependent source, you have diamond symbols. Remember. When I was teaching you about dependent and independent source, I said your dependent source, you know it by having diamond symbols. So that's exactly what you have on that. The one with blue caption is what you call dependent source transformation. That means you can do dependent source transformation between the dependent voltage source and dependent current source. You can do independent source by doing independent voltage source to independent current source. Please take note of all these things. The dependent source is always a diamond symbol. Please take note. And they can also be transformed if you run to a complex system. So when we are doing voltage source transformation, it's only the source that you are transforming. So that's why we call it source transformation. You must disconnect your output from it. But everything that makes up your source is what you are pulling together to give you source transformation. And if you look at Thevenin theorem, you will find out that the Thevenin theorem, you collapse all resistance or all resistors together, and you only pull out the output. But we are not yet there. That's my next lecture with you. But that's the principle that we normally will be using when we are dealing with the Thevenin's theorem and Norton's theorem. So on the account of this, you have seen how we do source transformation. You will need it a lot. You will need it a lot. Please take note of this. See it. Voltage source is always connected in series with resistors for to its internal resistance. It's always connected to its internal resistance in series. But current source is always connected to its internal resistance in parallel. That's why you have that RP. Note that RP and RS, they are of the same value. Take note of that. So let's look at this. Please, can you draw this out in your note? 3 amps is in parallel with 2.66 ohms. And then it's connected to 8 ohms. Because we are discussing source transformation, what we apply your source transformation principle to is just you will remove the output resistance, you will remove it from it. It will not be part of what will work for you. you will disconnect your output resistance, because you can see V out on that 8 ohm resistance. So it will not be part of your this thing. So in doing your source transformation, you will have your 3 amps. You will look for its voltage equivalent. So who can tell me how did we get that 8 volts?
So that would be
Yes.
2.66 times 3.
Yeah.
2.66 is the internal resistance, if I'm not mistaken.
Okay. Yes. Can you divide it for me and see whether I'm correct? Or do the calculation for me. What did you get?
7.98.
So that's why 7.9 is close to 8. Thank you. So that's the essence of that. So, but your resistance, did we change it when we transform to voltage source?
No.
No,
No,
sir.
sir.
So your resistance will be connected in series, no longer in parallel with, because in the source transformation, when you are moving from current to voltage, you will connect your voltage and your internal resistance in series. Or you will connect all the resistors that make it up in series. I'm going to something else now. Look at the one under, where we have like a ladder. Look at the one on your left, where we have three ladder system. You have the 4 ohms as your source, following it by the 3 amps current source. You have the 2 ohms connected, which has 2 other 3 ohms and 8 ohms. And we said that 8 ohms is our output. Recall? Can you see that as I'm seeing it?
Yes, sir.
So that means 8 ohms must not be part of your work when you are doing source transformation. Every other resistor there must be part of the analysis. But your 8 ohm resistor will not be, because we have identified it as what?
Our output.
So because it's output and we are dealing with source. Source is another name for input. So you cannot now tell me you want to analyze and join 8 ohms to it. It will be totally wrong. That's why I decided to put that 8 ohm in the middle. But I quickly did one thing. I identified it as what? As output. So if anybody does it, I will say, well, you have made a mistake. Or if anybody does otherwise, by including it as part of the source, then that fellow has made mistake. I hope you are getting what I am driving at, because these are fundamentals to your life in engineering.
Sorry, sir. How do you mean if anybody draws it? I didn't get what you mean by like if anybody draws it as part of, like where would we draw it and it would be wrong?
No. I mean, if you use it as part of your calculator for source.
Oh, okay. Thank you, sir.
You can't use it as part of your source. Because I've told you, source transformation is only the sources, current resistors that make up the source. And I have identified 8 ohms as output of the whole circuit. So that means you will not touch it or to your source transformation.
Oh, okay, sir. I have a question, sir.
Yes, go ahead. But you should have lifted up your hand, because I have many people who have their hands up. So let
I'm
me
very, very
leave with the
sorry,
people.
sir. Okay,
Lift
sir.
up your hands. You will join them, so that it won't be as if Adebisi, after Adebisi Oyekale, then Uchechukwu will follow. God, Uchechukwu said he will lift up his hand. So Adebisi, let me hear your question.
Okay, sir. You mentioned that 8 ohms as our output. So is it that we can just pick any resistor as our output, or it has to be made known in a particular question that, okay, this particular resistor is our output.
Okay. Is that the only question?
Yes, sir.
Okay, thank you. That must be identified by the examiner or whoever wants you to solve it. If he does not identify it, then all of them you treat them as source elements. That means when you are through, you will just open the other end that, well, I'm through. I don't know what you want to connect as your source, as your output. I don't know what you want to connect as your output, but you asked me to do source transformation, and I have transformed all the resistors I saw there. Since I didn't see anyone being tagged or marked or captioned as output, then I have to analyze all of them together. But in my own case, if you look at the first circuit, I give you V out. Whenever you see VO or IO, you should know that that's the output current or output voltage. So by putting VO on 8 ohms, it means that that's my output terminal. So a resistance that is connected there is output resistance. Thank you. Then let me hear from the what's the name of
Yes,
this
sir.
other guy?
Thank you very much, sir. I just wanted to know for like the second scenario, if 8 ohm was not the output, like can we involve it in the source transformation? Like how do we resolve it since we have 4 ohms at the left side and 8 ohms at the right side? That's if 8 ohms was not an output.
I think I've answered it with your other colleague's question. Once the examiner does not identify it, that it is your output. If you look at the first question, the first one we looked at, I showed clearly that this is output. And now I showed you another one, I said this is output. So definitely it means that if he does not show it, you will have to analyze all of them as source resistance or source resistors. But once it's identified, you don't include it in your analysis or your calculation. It will stand alone. Maybe you should wait till when I'm through with this, because our time is fast spent.
Okay, sir.
Okay. So if you look at this second, I put for 8 ohms V out. Now, if you look at it, when we are doing source transformation, you can see, if you look at the circuit on your left-hand side, you have one as current source, you have one as voltage source. And I have told you the one as current source, its own resistor that is connected in parallel to it is normally taken as its internal resistors. So on the account of that, that means 4 ohms is the internal resistor to 3 amps. I hope it is sinking. 4 ohms is internal resistance to 3 amps, while 3 ohms is internal resistance to 12 volts because it's in series with 12 volts. Remember, I taught you this, and I kept on emphasizing it. So the parallel resistance to current is the internal resistance. So when you are going to transform the current source to a voltage source, it is that 4 ohms that you will use for your analysis to transform it to voltage and resistance. And remember, I've told you that that resistance will not change value. It's only the current source that will become a voltage source whose value will change. And if you want to look at this, 4 ohms and 3 amps, if you multiply it, you will get 12 volts. That's why we got that 12 volts. And if you look at it, the direction of the current is pointing downwards. And we have said that it flows from positive to negative. So the negative will be on top, unlike what we are used to, and the positive will be under. The direction of the current is telling us how we will put our positive and negative terminal for the voltage source. The direction of the current is showing us how we will put our voltage and current source. I think Alosie still picked me up on this last week, that when I told those people that when you move from negative to positive, it will give us positive answer. I said yes. So you can see it's moving from negative to positive because the arrow is going down. So it is from negative will be on top, positive will be under. And so the resistor, 4 ohms, will now be in series with 12 volts. 12 volts is obtained by 4 ohms times 3 amps, which gives us 12 volts. But now the resistor, 4 ohms, which is the internal resistance, will now be connected in series with the 12 volts. So that's why you have what you have. Somebody is disturbing my class. So that's the transformation of the current source to voltage source. Then looking at the voltage source on the right-hand side of it, where you have 3 ohms in series with 12 volts. You can transform it as well to a current source. But before we do that, who is this disturbing my class, please? So before we do that, we have to finish with the voltage source. The voltage source now has the new voltage source that we have brought in as source transformation. We are now connecting that 4 ohms that is in series with the voltage 12 volts. We are connecting it in series with the 2 ohms that have been there before its arrival. So the 2 of them are now in series because the same current will pass through them. You don't need to make any decision in moving from one end to the other of the other one. So the 2 of them will be added together to give us 6 ohms. And now you have 6 ohms, 12 volts, and the other side you have 3 ohms, 12 volts. But you still have your output voltage with its resistance in between the 2 of them. When you have this kind of situation, current analysis is the best for you. Current analysis approach is the best for you. So you can now turn the 2 of them from voltage sources to current sources. And in doing that, that means the resistor will now be in parallel with the current source. So if you are doing that, we have 6 ohms on the left side of the 8 ohms, 6 ohms, and you have 12 volts. What is the current? Current by Ohm's law is 12 volts over 6 ohms. And that will give you 2 amps. But the resistance will not change. It will just be in parallel with the voltage source, current source. Then on the other side, you have the 3 ohms in series with the 12 volts. And then you can then get the current by saying 12 volts over 3 ohms. That will give you 4 amps. But the resistor, 3 ohms, will now be in series in parallel with the current source. That's why we are having. Hello, engineer, I will join now. Hello, I will join now. I'm in a lecture, but I will join right away. Okay, sorry for that. Okay. So, guys, I have another meeting now, an international meeting for that matter. So, we'll continue from here next week. If you have your question, just jot them down. And then we'll continue from here by Tuesday next week. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Please remind me of where we stop next week so that we can continue from there.
Okay, sir.